from MIT 2023. This is semifinals round 1 problem 3. As you can see, we've got all kinds of cosines in this problem, but with different angles. It's really hard to know where to start with something like this because there's so many different options. With trig identities, we could kind of approach it from any of these, but we want to get it where we're going to get some cancellation. One thing I'd like to do if I can is get as many things with just a single angle as I can. So here we just have a cosine x. And with this, with just a cosine 2x, I can transform this pretty easily. Now we do have the identity that for sine squared x, if we wanted to reduce that, it would be 1/2 1 minus cosine 2x. So this is the same as this. If I just multiply a 2 on both sides, then we can write this thing as 2 sine squared of x. But everything else in this problem is cosine, so I don't really want a sine, so we can just rearrange this using sine squared plus cosine squared equals 1, and that's going to allow me to write this as 2 1 minus cosine squared x. And then finally, we don't have anything squared. We have everything as just the first power. So for this, I can just split this up, difference of 2 squares, and write it as 1 plus cos x, 1 minus cos x, and we'll rewrite the denominator like this. Now, one nice thing about this is we got a 2 here, and I'm starting to see this pattern that we have a 2 on almost everything except for this term and this term. So let me just work on those two terms. I can factor a minus sign out of those, so we'll have, I can write this as cosine 2021x plus cosine 2023x. Well, for this, there's another trig identity we can use. We're going to use pretty much all the trig identities in this video. So if we have something like cosine A times cosine B, this is going to be the same thing as 1/2 cosine difference of the angles plus the sum of the angles. So in order to use that, what I want to do is kind of align this piece with everything we have inside the parentheses. In order to get a formula for it, let's multiply in by a 2 on both sides, so this cancels out. And now in order to use this, it's just kind of a question of what our A and B is. We're saying we want A minus B to be 2021x, and we want A plus B to be 2023x. Well, you can solve this little system however you want to do it, but what's going to happen is A is going to be 2022x and B is going to be just x. So we can use this and put it in this form, just filling in our A and B. So this is going to become minus 2 cosine of the A value, which is 2022x, and the B value is just x. And so that's going to allow me to take this value right here, and we'll plug it back in for our cosine 2021 and cosine 2023. Okay, now that we have that value from the previous board plugged in here, now we have the 2 on everything. So at least we start getting some cancellation because I could factor it up. Let's just cancel it on the fly, canceling the 2's out of everything. If I cancel this one, it's going to be a +1. And then here we can do some more just rearranging, reordering. Let's group cosine x and +1. And actually, let's write it as 1 plus cosine x over here, just putting those two together. And then from this one and this one, we've got cosine 22x in common. So I'll factor out cosine 2022x. But when I do that, we get another 1 plus cosine x. And now what happened is we've got 1 plus cosine x in common here, here, and here. Again, we could factor, but let's cancel on the fly. So if I cancel and cancel this one with this one, cancel this one, that's just going to leave me with a 1. And so when we clean it up, we've got something quite a bit simpler looking. We got 1 minus cosine 2022x over 1 minus cosine x dx. Now, the first time I did this, I got to this, I was pretty excited, and then I realized I don't necessarily know how to do this integral. I wanted to multiply in 1 plus cosine x, but that's kind of pointless because we just factored it out. It looks almost like we could do a Weierstrass substitution, except it's probably not going to work well with this cosine 2022x. Well, let me just clean up the board and we'll deal with this thing now. So even though I didn't want to use a Weierstrass substitution on it, I did notice the similarity between this 1 minus cosine x and our half angle formula for sine. That's got the same thing in common. In order to work with this, let's just square both sides on this. So then we're going to have sine squared half x. Plus or minus is not going to matter when we square it. It's going to always be positive. Gets rid of the square root. We end up with 1/2 1 minus cosine x. multiply by 2 on both sides. It seems like we've already done that like 5 times in this same video. So multiply by 2, we've isolated our 1 minus cosine x, and now I can take this value and we'll plug it into our integral. So putting this back, I've pulled the 2 or the 1/2 out front. Now at this point I still don't really know what to do with it because our angles don't match, so it seems like we might be making things worse. But what I can try now is integration by parts on this. We'll use the DI method, and the way I want to do this thing, it's hard to deal with. I mean, we don't know how to deal with it to integrate it, but I can definitely differentiate 1 minus cosine 2022x. And then I'll integrate this, bring it into the numerator. To integrate it, I can write it as cosecant squared x over 2. So then we'll go ahead and differentiate. Derivative of cosine is going to be minus sine. Minus times minus is plus. And then we're going to have 2022 pop out in front here. Over here, derivative of cosecant squared, that's going to be minus cotangent x over 2. But with the 1/2, a 2 is going to pop out in front. So then let's just deal with the diagonal for a minute. So this is going to be 1 minus cosine 2022x. I'll bring the minus 2 over here, and then we're going to have cotangent x over 2, and this is evaluated from 0 to pi. Well, when you plug pi in, cotangent of pi over 2 is going to 0, and so this part's not going to matter, and so this part's going away to 0. You plug a 0 in, this part is 0, but this part's going to infinity, so what you have here is an indeterminate form. If you work this out, you can do this just L'Hopital's rule. What's going to happen is this whole thing, when you do the limit, is going to be also going to 0, so this goes away. So we just don't have to worry about evaluating this part, and we can just deal with this right here, writing it as an integral. So for this integral, minus times minus is going to be plus. We're going to have 1/2 in front, but then let's use this 2 here to cancel that, and then we're going to have this 2022, and then what's left, we're going to have this integral going from 0 to infinity. Now sine, what I'm going to do is I'm going to separate out the cotangent. So we're going to have sine 2022x in the numerator. Cotangent is cosine over sine, so we're going to write this as sine x over 2 here, and then cosine x over 2 right here. But for this thing right here, we can just use a different angle formula for sine and cosine. Like I said earlier, we're really using all of our trig identities. So we'll use this formula here where like our A value on this is going to be 2022x and our B value is going to be x over 2. We're going to plug into here. First, I can take the 1/2 out front. I think I'll leave it unreduced. So we'll have it as 2022 over 2, even though I could write it as 1011. And so this is going from 0 to pi. Then using this, I'm also going to not reduce this for now. So I'm going to write this as 2022x minus x over 2. And then for the second one, we just need to add the angle. So it's going to be sine 2022x plus x over 2. Now, one thing I can do with 2022x minus x over 2, this might seem a little odd, but what I'll do is I'm actually going to subtract 1 from this part, and we'll have 2021x, and add 1 over here. So we have plus x over 2. So this way, if I replace this in here with this, I've written my angles both the same way, so that in both cases we're adding x over 2. And now that I have it like this and we're separated here by a plus sign, let's just split this up into 2 integrals. Everything's going to have this 1011 in front. And now at this point you may recognize this. Both of the integrals we have, both of these are set up to use the formula for the Dirichlet kernel. We have this formula where we need the denominator to be sine x over 2. And actually the integral is not included in this. It's really, we're just talking about a trig identity for the inside stuff. And for this one, the n value in the formula is going to be 2021. And over here, the n value is going to be 2022. So we'll come up here and I'm just going to apply this formula. We'll keep this value in front and we're still inside the integral. So for this first one, it's going to be 1 plus 2 times the sum from k equals 1 to the n value. So 2021 of cosine kx. And then for the second one, basically it's identical, just with 2022 as the upper bound here. The first time I did this, I was trying to manipulate these sums and bring them together. It's really not necessary because if you think about this, this is going to create just a whole bunch of cosine integrals. So we can kind of just generalize this and look at one of these integrals. We're integrating 0 to pi. There's going to be some constant in front, I guess. It's going to be like a 2, but it doesn't matter. So we'll just say there's going to be a constant in front of this, and we're going to have some cosine kx. And we know that k is going to be an integer. We go ahead and integrate this. We're going to get sine kx over k, but we're evaluating from 0 to pi. Well, you'll notice the 0 value is always going to be 0, and then the pi value also, when k is an integer, it's still going to be 0, and we don't have to worry about the case when k is 0, because in both cases k is starting at 1. So what happens when we expand this out? Even though it's 43 different integrals, they're all 0. So this one is going to 0, this one's going to 0, and all we're left to deal with is 1 plus 1. So putting this all together, we've got our 2022 in front over 2, integrating from 0 to pi of just 2 dx. I'll cancel 2's here, integrate 1. We're left with 2022 times x evaluated from 0 to pi. Evaluate, and for my final solution of this, we just get 2022 pi, and that's it. Okay, so there you go. Not a lot of integration involved. It's just a lot of trig. We used like 10 different identities. I'm probably exaggerating. Maybe it was only 3, but it just felt like a lot of trig in this one. So that's it for today. Thanks so much for watching. Have a good day.